The functionality of a basic reset set, or RS flip-flop device, can be demonstrated by observing how input pulses on R and S, factoring in a time element, affect the outputs Q and Q naught. At time period T1, we have a 0 input on the S, or set, and a 1 on the R, or reset. This results in a low on the S, which activates and sets the output of Q to 1, with Q naught going to 0, or the opposite of Q. At T2, an input of 1 on the set and a 0 on the reset will command Q to go to 0. Thus, Q naught will be at 1. At T3, there is an input of 1 on the set and a 1 on the reset. In this case, it is not commanding the circuit to do anything, and the output at Q remains at 0, with Q naught staying at 1. At T4, changing the input on the set to 0 while a 1 remains on the reset input will command Q to go to 1, with Q naught going to 0. At T5, both inputs on the set and reset are at 1, resulting in no change in the outputs. Finally, at T6, the input at the reset is changed to 0, with the set remaining at 1. This commands the output at Q to go to 0, with Q naught going to 1. The JK flip-flop has all the elements of a typical flip-flop circuit. However, the reset and set, or R and S labels used in the logical symbol for a basic RS flip-flop, are now labeled PS for preset and CLR for clear. Additionally, there is a data input at both a J and K terminal. There is also a clocking input, labeled CLK, that when activated can influence the state of the flip-flop. Importantly, the bubble with the greater than symbol alongside the CLK label indicates that the flip-flop will be activated when there is a high to low transition of the input clock pulse. Let's input a variety of time-based pulses represented by the various waveforms in this diagram. In this circuit, keep in mind that the preset and clear inputs will take priority over any other inputs. Thus, if either the preset or the clear goes low, they can change the state of the flip-flop regardless of what the inputs may be elsewhere in the circuit. Let's input a variety of time-based pulses represented by the various waveforms in this diagram. Here we have the inputs to the preset and clear, the synchronous inputs to J and K, and the input of the clocking pulse. The clocking pulses are represented by T1 through T8. They operate on a negative edge triggering. Thus, the flip-flop is activated when the clock impulse goes from high to low. Now, let's observe the output we would expect at Q as we operate this circuit with various inputs. The Q naught waveform is not displayed in this time-sequenced output graph, as it is assumed to be the opposite of Q. At T1, the preset input is 0 or low, thus Q remains high. At T2, the input to both J and K is 1 or high and hits a clock pulse, thus Q toggles to 0 or low. At T3, the input to J is 0 or low, and the input to K is still 1 or high. Thus Q remains at 0 or low. At T4, input to CLR is low, and thus will take priority over any other input. Thus, Q remains at 0 or low. At T5, J is 1 or high, and K is 0 or low. Thus, Q goes high or back to 1. At T6, J is 1 and K is 1, and you hit another clock pulse. Thus, Q toggles to 0 or low. At T7, J and K remain at 1 or high. Again, you hit a clock pulse. Thus, Q will toggle back to 1 or high. At T8, both J and K go to 0 or low. Thus, Q remains high.